V. Phadke, India head from Global Cement and Concrete Association. I invite our co-chairman on the dais, please. To represent NCB, I take pleasure in inviting Dr. Pinky Pandey, Group Manager NCB, on the stage to conduct the session. I invite Dr. Pinky Pandey on the dais to conduct the technical session.
It's okay? Okay. I welcome Shri Vimal Jain, Director Technical, Heidelberg Cements India Limited. Shri Jain is a Bachelor of Engineering in Mechanical and PG Diploma in Business Management and Projects Management. Also, he has been associated with Heidelberg Materials Group since 2007. Previously, he has been associated with Heidelberg Technical Center, Indonesia as Project Manager. He has also worked with RAC Cement, UAE, Prism Cement, and Remote Cement in various capacities in projects and mechanical fields. So this is a brief introduction of our chairman of this session. Welcome, sir. And next, I introduce our co-chairman, Shri Kaustuv V. Phadke, sir. So he is India head of GCCA, and he is an environmental engineer and a certified green building assessor. He has got more than 22 years of experience in sustainability, carbon footprint, mapping, water stewardship, sustainable supply chain management, and EHS management system. He has also worked as a technical consultant for UN Environment Program and worked on development of integrated reports, business responsibility and sustainability reporting, sustainability roadmap implementation, sustainability practices in supply chain, implementation of EHS practices, and liaising with pollution. So this is for our co-chairman. Now I request our chairman to start the session. Please.
Thank you for good introduction. And now I request the presenters to start the session. And for each presentation, there are total 8 presentations. For each presentation, we have allocated approximately 8 to 9 minutes per presentation. And afterward, we will take around 2 to 3 minutes question and answers. So now I request co-chairman to invite the first presenter.
Yeah, good evening, ladies and gentlemen. It's really my pleasure to co-chair this session on the alternative waste fuels and the raw materials. The first session is by Mr. Nitin Jain. The topic is a game changer and reinventing the primary shredder for AFR pre-processing from Fornnax Technologies Private Limited. Mr. Nitin Jain.
Good evening to all and the dignitaries. Myself Nitin Jain from Fornnax Technology. I am here as a presenter on the 18th NCB International Conference on the topic of a game changer and a revolutionary primary shredder for AFR pre-processing. So what is AFR pre-processing? So pre-processing is the process of converting waste into the AFR. So in our cement industries right now we are majorly focusing to switch as an alternative fuel. So we have to understand that what is this process and what is to be taken care of to do this process effectively. So pre-processing generally includes the primary shredding, separation, screening, segregation, secondary shredding, and foreign body removal, etc. So equipment selection and installation should be aligned with the equipment and the process of the maximum results to be gained from it. So we have to select the right machine for our waste so that we can pre-process our AFR effectively, and for this the complete process is to be taken care of. So why pre-processing of waste is significant? There are very related processes which is to be taken care of for giving this significance. The resource recovery should be there, cost reduction, there is a pollution reduction will be there, sustainable practices, improved workplace, energy efficiency, and long-term sustainability. So these are the few significant factors due to which we have to use the pre-processing in our equipment. But as we have gone through to this industry, we have found out many pain areas which are to be taken care of during this pre-processing of AFR material. So the major one that we have found out is of the improper layout. Coming to that improper layout is we are not understanding the process, as our Indian waste and the legacy waste is totally different comparative to the machines that we are using into our industry. So based on that, the layout should be in such a way that the waste which is to be segregated and to be processed, the equipment should be aligned with that requirement. In our waste, there is a high moisture and the wet waste is being available. So to cater this, the primary shredder is to be have on a first place. As a layman, we can say they are just a biting teeth, because whatever the waste that we are collecting as a industry, we have to first shred it into some sizes on which we can pre-process it further. Secondary shredder are basically like chewing teeth, as it further do the size reduction of the material that we segregate after the primary shredding. So this material is perfectly being used by the calciner or the kiln to feed into the process. The other pain point is the output capacity issues, because if the right model or the pre-processing is being not selected, there are chances to not get the desired output capacity from the equipment or the capex on which we are investing. There is a missing equipment gap analysis as well. We are directly jumping on few of the equipments to pre-process our waste, and we are not going aligned with the equipments which are to be placed before or after the shredders. There are high maintenance costs for the secondary shredders, because if we are feeding our legacy waste directly into the chewing teeth, it will do the high maintenance and the operational cost will increase drastically. There is a high contaminated waste considering the legacy waste that we are catering into in India basically. And the last, and not the least, is the after-sales service support and the issues. Because these equipments are of wear and tear equipments, so it requires a rigorous maintenance even after the installation of the equipment. So you require a good OEM who gives the good sales and after-sales service with spares. So before coming up with this layout, we have been visited up from around 60 plus plants within India. And what we have found out is this is the existing pre-processing equipment layout which is being going on in our industry right now. So there should be a primary shredder that we have as a company has launched as SRMax 2500. It will give you the output of up to 150 mm. Then there should be a overband magnet which will remove all the ferrous content which is being produced or which is incorporated into the waste. Then there should be a disc screen. Disc screen will give you the sizing of around 80 mm, which is the desired output size of the industry, to feed into the calciner. And if there is any oversized material, you can refeed into the same system. So this is a phase 1 system which is generally being utilized by the pre-processing equipment in major industries in current scenario. Ideally, the pre-processing equipment layout should be in this frame. As we have seen earlier, the disc screen will give you only the sizing to be screened up to 80 mm. So the above size, which is more than 80 mm, it shouldn't be refeeded into the same primary shredder. You should further do the screening of it through air density separator, that is a wind shifter. So here all your inert material like stone or any non-ferrous part will get separated, and only the fluffy material which is being utilized for further making the RDF, it will be passed on to the next system. Then there should be a secondary shredder. Here it will do the work efficiently, as it will be free of all the inert that has been fed into the primary shredder. So here the machine will run effectively, and it will give you the desired output size of in range of 30 to 80 mm that is being required by the industry to feed into the calciner. And the rest of the material which is being segregated as an inert from the wind shifter, you can further pre-process it through an eddy current separator to separate the non-ferrous content, and the inert material you can dump into the grave. So this is what as a Fornnax we are proposing. We have our own launched primary shredder SR-Max 2500, which has an input capacity of up to 40 tons per hour, up to size of 150 mm. After that, we have shown an overband magnet, then a disc screen which could be sized as per the requirement of up to 80 mm. Then there would be a feeding conveyor which will pass on the oversized material to the air density separator. And after the air density, there should be a secondary shredder which will take care of the final output size which is being desired to feed into the calciner. So this is our primary shredder SR-Max 2500. This machine we have launched last month in one of the premium exhibition of IFET India, and we have also showcased it in NCB. So I would like to welcome you all to please come up at our stall and have a look of the machine. It's a machine which is completely made in India. So this is just a brief video to understand what is the process and what is the thing related to it. So the major challenge is for the maintenance. So we have taken very feedbacks from the various people into the cement industries. So here the cutting cartridge is detachable, and the shaft can also be removed. So, and all the shaft and the bearing housing is being detachable. So here you can work efficiently by you have to regrind the knives easily. You can regrind it on the machine, or else you can also keep it in spare to better utilize of the machine.
Request Nitin to please expedite.
Yes. So these are few of the salient features as we have discussed. Other than this, we are also into the manufacturing of electric drive machines for the similar application of municipal solid waste, which we are catering up to 20 tons per hour. So as a Fornnax, we are into the industry of recycling since last 13 years now. We are already pioneers in the tire recycling industry. We are catering more than 90% market share within India for the tire recycling, and we are also globally present in Europe, Australia, in Middle East. So now we are entering into the municipal waste industry for the cement and the power plants to give them a made in India machine of the primary shredder of high capacity to give a sustainable and to achieve the Prime Minister vision of made in India. Thank you and most welcome to visit our stall.
Thank you, Nitin, for your good presentation. Now we request co-chairman to invite the second presenter. So we will be taking question and answer at the end to save some time.
Yes, the second presentation is by Mr. Keshav Katare. He is going to talk on alternative fuel and raw material co-processing experiences in cement plant with high chloride in limestone. Thank you.
Respected Chairman Sir and dignitaries, I am Keshav Katare and presenting here the case study of the alternative fuel and raw material co-processing. So, this co-processing of the alternative raw material and the fuel till here, it is nothing special everyone is doing, but with high chlorine in limestone, it is a experience which is to be shared here. For that I am here. So, friends, plastic pollution, we all know that most pressing global environment challenge nowadays. We can see at this left-hand side photograph. This photograph is of our nearby city area where this whole municipality waste is dumped. We can say it is the pile, but I can say it is the mountain of the plastic and the waste, which is to be considered and we is to be take care. And we all are here in the Yashovumi. But what I am seeing since morning, that I have a plastic bottle. But I can guarantee it, after 3 days, Yashovumi, this conclave, this seminar will generate minimum 50,000 this kind of bottle. And this all bottle will be reached there only. So this is the challenge, and taking the lead to address this challenge, Marwar Mundwa take initiative, because it was already having the high chlorine. Marwar Mundwa cement plant, Ambuja cement plant in the Nagore city, very young plant because commissioned in the 2021 only, having the 10,500 ton clinker capacity and long kiln of the 84 meters. So challenge what we discussed, that is limestone chlorine deposit sometimes goes up to the 0.06%. That is too high. So for that point we have taken this project. Sir, so this plastic considered as the AFR also. So most of the AFR are the low grade fuel because it is having some kind of this calorific value. So plant used two type of AFR right now. One is the RDF. RDF is nothing but municipality solid waste, which contains maximum plastic, paper, cardboard, cloth, wood, rubber, etc. and some part of biomass, because it provides a significant employment to the rural area. So these are some basic rules for the being mastering of the co-processing. And this is the Marwar plant readiness checklist. Because we understand, we know, if we have the better planning, that half job is done. So this is the planning or checklist. If we fulfill this checklist, we will get the results. So inline calciner, sufficient residence time, there is a need for the co-processing, sufficient O2 level, there is the addition reserve, orifice velocity, stable feed, LGF preparation. These are some of the readiness checklist. Now, what is the process challenge with this RDF, AFR and high chlorine in the limestone? The process challenge is the mainly volatile element recirculations. So, these volatile element recirculations, these elements at the higher temperature goes into the circuit again and again, and it get deposited in the process. So in case of the Marwar Mudwa limestone, it is having the already high chlorine content. Chlorine content in cement plant generally expressed as a gram chlorine per ton of clinker. And it comes from the limestone, it comes from the fuel, it comes from the RDF. So in our case, it is the 600 to 650 gram per ton of clinker, that is very high side. And sulfur content, sulfur is also a volatile element, and sulfur comes from the coal. Marwar is using high sulfur Saudi petcoke, which is extremely high. It is near about 8 to 9%. In left hand side corner, we see there is a template, there is a graph. There is some three colors are there, green, yellow, and the red. So on the y-axis, it is the chlorine content. Chlorine content is the hot meal, which is the lowermost cyclone samples. And right hand side, it is the sulfur. So if chlorine is high and sulfur is high, we can see it is the red zone. Red zone is mostly, it is a frequent blockage. Frequent blockage means it interrupts the production, it damages the quality, it interrupts the hours availability of the kiln, and sometimes it's a hazard, it's a safety also. And the right hand side, we can see this dotted, blue dotted line indicates that Marwar is already in the frequent block zone. So this is a chlorine and sulfur input control management. For chlorine in cement plant, it is difficult to control, but yes, sulfur up to the somehow. So on left hand side, chlorine input is the 600 to 650 gram per ton of clinker. Optimum range is the less than 300 to 400. Higher side, A by S ratio, it can be managed, it can be maintained because it is nothing but alkali above the sulfur. So, but it is the guideline. So it is within the guideline, and sulfur volatility, we are less thanks to new generation burner. For that we are having the good combustion rate. And hot mill zone, last we seen the picture showing people who are cleaning this one, having this kind of dress and do this kind of job. This is the supportive equipment and the main design for the plant. So with this mill cut and high retention time, number of air blasters, which is nothing but the self-cleaning device. After that also multiple port for the effective manual balancing, and well-maintained instrument is also important, especially kiln inlet analyzer and the temperature and the draft sensor. Definitely use of anti-coating silicon carbide bricks is needed. So solution adopted and action implemented by the plant is the usage of the red mud. Red mud is itself a waste of the aluminum industries. Up to the before some time only, red mud disposal was itself a big issue. But now it is being used the cement plants. So this red mud is having the, we can see iron percentage which can replace the one corrective material known as the red occur. And along with that, it is having the higher percentage of the Na2O, that is the alkalis, that help in the alkali sulfur ratio what we seen. So it mitigates some ill effect of the sulfur, and it helps to remove the sulfur from the circuits. And usage of anti-coating bricks we discussed, kiln operation control, enhanced filter cleaning, installation of HLC. HLC is the high level control, known as the physiology, if you heard this one. So in graph we have seen that red color line is the temperature control inside the kiln. So if we are having the better control of the temperature, better the process, we can go for the more usage of the alternative fuel and the raw materials. Here we can see this on left hand side graph. We can see that there is the orange bar and the blue bar. Blue bar is the red mud percentage which we are used, and orange bar is the chlorine. So we see that in the first part chlorine in hot mill is the higher side, but as soon as we increase the red mud uses, dry red mud uses, we find that chlorine is coming down. Although theoretically some of gentlemen may not be little bit agree with this point, but in fact Marwar get benefited with this red mud uses only. In right hand side graph we can see that increase the usage of the TSR, that is equal to AFR, increase usage of the AFR, plant added and increases use of the red mud. Here the results we can see here. Upper one is the in ton, that is 18,655 ton, and bottom line is the TS in terms of the TSR percentage. So since December 2023, plant has started usage of the AFR, LGF, plastics, etc. And in 11 months, plant has successfully used 1.7 lakh ton of this plastic waste, which we seen in the shape of the heaps. And here is the conclusion. Marwar plant using AF at 20 to 22% higher concentration in the hot meal, which was considered to be non-feasible till now. And this one plant lead to take the FR users to the next level. This is not a milestone, this is a journey. And this can be copied with pride by the industry. Go for more use green fuel, alternative fuel to reduce carbon footprint for a sustainable future of the planet. Thank you very much, sir.
Thanks, Mr. Keshav. Now we invite third presenter.
Yeah, third presenter is Mr. Sumit Nalawade. He's going to talk about innovative interventions for enhanced alternative fuel combustion in cement plants from UltraTech Cement.
There is a correction. Myself, Ramesh, actually. Yeah.
So, you are Mr. Ramesh Kunuku?
Yeah. Ramesh Kunuku.
Okay.
Okay.
Yeah, Ramesh, please.
Yeah, thank you, Chairman and Co-Chairman. Good evening, ladies and gentlemen. My name is Ramesh, currently heading the Process Modeling Department at UltraTech Cement R&D Center. Today, I will be discussing how we have enhanced the AF combustion efficiency levels in ILC through innovative approach without any major capex. I'm sure applying learnings from this topic at your plants, you can also enhance the AF combustion efficiency levels and minimize associated kiln operational issues without any major capex. The next slides will outline the core components of our today's discussion. Initially, we'll have a look at what are the problems associated in ILC due to incomplete combustion of AF. And then we will discuss how systematically we have used the CFD tool and help and in terms of analyzing the combustion zone and come up with cost economical, innovative, in-house solutions. And also we'll see what are the major benefits we got after the minor changes in the ILC. Plant predominantly uses MSW and plastic waste as AF. With increase in AF, the plant faced the problems like material accumulation in the feed chute and high CO formation at the calciner outlet. The CO levels are more than 0.2% even at 3% oxygen levels, which is indicating incomplete combustion of AF in the calciner. So one of the solutions envisaged by the plant was conversion of the existing chute into 2 AF feeding chutes so that the AF particle dispersion will be increased in the calciner. This particular modification requires capex and also the shutdown time because we need to install the secondary chute and elevate the existing preceding belt conveyor for feeding into both the chutes without having any problems in the chute for the AFR material flow. So we have taken up this challenge and developed an innovative in-house cost economical solution which does not require any major capex and additional shutdown. Next slides will outline the CFD tool and systematic intervention and analysis of the combustion zone of ILC and how we have formulated the innovative solutions like inserts, MDS, and enhance the AF combustion levels. This is the table showing the process data and AF fuel analysis used for the CFD modeling. Currently, the plant uses AFR is about 12%. The CFD result shows that in the existing ILC, the coal was injected in the kiln riser duct, and at 2 locations which are opposite to each other, the coal is distributed across ILC properly, and with a residence time of more than 4 seconds, it is combusted completely. We can see the green color in the center image. Whereas AF was fed from the right side to the calciner, and we can see after injection of AF into the calciner, the lighter material has been lifted due to the drag force by the gas, and the heavier lift material was tending to fall down. We can clearly see uneven distribution of AF particles in the calciner. So, ladies and gentlemen, it is not only important for a fuel to complete combustion, it is not only important to have a sufficient residence time, and the fuel and gas should be mixed properly. They should be mixing properly like friends, but in this particular case, they are following different paths and acting like enemies. So to make these enemies into friends, we have introduced some innovative solutions like introduction of a notch below and opposite to the existing feeding point, and we have improved the mixing with the help of another notch above the AF feed injection. And also, we have developed an innovative material distribution system which was installed near to the AF feeding injection. With this, we have enhanced the AF combustion efficiency, as well as we have reduced the material fallout inside the kiln. So, with these minor changes, we have achieved the combustion efficiency levels improved by 10%, and the CO at calciner outlet has drastically reduced from the levels of more than 0.2% to the levels of less than 0.1%. This is possible due to the particle dispersion improvement in the ILC. Similar levels of AF consumption levels has been increased, and we can achieve the return on investment with these minor changes less than a month. So ladies and gentlemen, these learnings you can directly apply at your plants, and you can enhance the existing AF consumption levels at your plants without any major capex. So let me conclude by saying that a systematic intervention and use of modeling tools and analyzing the combustion zone in the calciner or in the main burner, we can create or develop the cost economical in-house solutions and improve the current AF consumption levels, which is the need of our today's cement plants. And thank you, Chairman and Co-Chairman, for giving me this opportunity. Thank you all.
Thank you very much for maintaining the time and having your good presentation. Now we invite fourth presenter.
Fourth presenter is Mr. Abhay Dwivedi and Diwakar Naidu. The topic is a sustainable milestone in cement manufacturing by achieving 35% thermal substitution rate from Aditya Cement Works, UltraTech.
So very good evening, respected chairman, sir, co-chairman, and all delegates, all industries, ladies and gentlemen. Myself, Abhay Dwivedi. I came from Aditya Cement Works, which is located at Chittorgarh, Rajasthan. So So the same, my topic is same as last presenter has already shared the same case study, which is related with the TSR journey. We started from 10% to 35%. So the presentation flow is our introduction, background, objective, experimental design, CFD, operational challenges during the operation, what we have faced and how we have improved from 10 to 15%. AF material, how many materials we have used, experimental work, observations, result discussions, and way forward. So our case study is, we present the case study for achieving a 35% TSR from alternative fuels at Aditya Cement Works at line 3 through the various capex and in-house activity. Actually, background of this project, because the fuel cost is all, in the cement industry, major production cost is the 70% cost is the fuel. Secondly, when we started this particular project, just post the COVID area. And that time, we have all faced scarcity of the fuels. Cost is too much high. And that time, our in-house team and with the great support of our itself R&D team, they have well supported, and we have taken the challenge to enhance our TSR from 10 to 30%. So FR uses conservations, natural fuels, and also reduce the carbon footprint. The object is that. Aditya, there is one picture is showing, which is a unit Aditya Cement Works having the 3-line clinkerization capacity, having the capacity of 7.1 million ton, and cement grinding capacity is 5.0 metric ton with the 3 number of captive power plant, and with the installation of 29.4 megawatt of WHRS, which is green, which is also reducing the carbon footprint, and we cater the almost 7 grinding unit at the north clusters. So about the Aditya plant, we have the double steering 6-inch preheater tower, particular line 3, because this case study belongs to the line number 3. And earlier this particular plant designed with the 6,000 TPD, and earlier we are operated prior to project 7,000 TPD with 8 to 9% of the TSR. And why we are using the 8 to 9%? Because there is a common circuit, feeding circuit for line 2 and line 3. So both, one common circuit feeding for the both plant, earlier we are using 8 to 9%. So what were the problem? Limited feeding and handling capacity, old system was a bottleneck to enhance the further co-process the AFR. So the object was to enhance the alternative fuels co-processing handling capacity from 10 to 35% TSR for the Aditya line 3. So what were the challenges? Incomplete combustions in AFR in the calciner, same as the last presenter has already told the same kind of case study. So to overcome from that particular challenges, we have design and layout constant in erection dedicatedly the feeding circuit. So feeding circuit was already I told there is a common feeding circuit for line 2 and line 3. Next, sustainable sourcing of alternative fuel. So because our plant is having 3 number of lines, so directly required around 15 to 1800 metric ton of the daily FR. It is one of the biggest problem to immediately to search the alternative fuel options. Material availability issue during the feeding, during the operations, and during the processing, hot mill volatile concentration. SR management is one of the concerns. So process breakdown due to pyrojamming. Sometimes we are increasing the FR, and that time we face various places jamming, especially in the FR suit. So we again we done the CFD analysis. That is CFD analysis to where to be the feed the material to at least get proper combustions with the without CO formations and with the proper combustions. So earlier if you see the picture, first one is the side view, and the second is the closed view. So earlier, prior to CFD, we are using the only one point. FR feeding is there, where with that particular point, with help of we are using around 10 to 15 metric ton of the FR. And after CFD, we got information and their recommendations based on. So we just above the TAD, we have two feeding sites vertically, where we are feeding around 12 to 12, around 15 metric ton, another with the stage formations stage formation AFR feeding system. So new twin F feeds should install in the pre-cancellations 52 meter, and with second, safety modeling was done for AFR particle trajectory, gas temperature, profile, and velocity. New tin feed suits installation at 60-degree pre-calcination, and after installations, this we are getting better burnability, better combustions. So, based on the recommendations, there was a feeding circuit constant, and because of 3 number of line at a one particular places, we have a very space constant. To address the facing the circuit bottleneck for installation of new FR handling feeding system, we introduced innovative civil structure, metro column, to overcome the space constant. You see the picture, we have installed in the metro column, and to replacing the conventional steel structure, key structures, and we have constructed around 6 metro column. Maximum height of the one metro column is 65.4 meters. We have installation one more extractor, grab gain, shader 4 number, belt conveyor, and apron. So these are a few capexes we have added for continual improving the FR and feeding circuit purpose. To experimental design, after feeding the FR, we have implemented some of the digital initiative like Killen Intelligent Vision Camera. So if you see, there is a three pictures. One is the yellow, second is the green, and third one is the red. So there is so capture the real-time image. Front end identify the kill conditions: hot, healthy, and dusty. So there is a scale 1 to 3 is kill is the dusty, it means not healthy, and 3 to 7 is kill is a healthy, and above the 7 is the kill is hot. So based on the based on the ratio, automatically this particular intelligent vision camera is operating the coal conjunction. So here also we save the fuels. Coal dosing rate control as per visibility index. So this is already implemented, and apart from that, to identify the AFR feeding continuously, to observing this, we have a AFR quality analyzer, wave-based, which is predetermined. We have given the data based on the size and based on the size and pictures. So based on that, predetermined analysis is providing so that during the operation of the kiln operator, they can understand which material is feeding and what is the ratio. And in case of any kiln dusty, either in case of any observation is there, so immediately that next counter action can be taken. Next.
So these are the results and discussions. As we have observed that there have been operational challenges, but we have overcome that by maintaining alkali-sulfur ratio. And as we can see, most of the values in the normal distribution curve fall in the range of in and around unity. And yes, clinker production TPD has reduced by 200 to 300 TPD from 7,000 TPD level. But gradually we have managed to increase the TSR percentage up to 35%. The results are, at this rate, we will annually consume around 2.25 LMT of alternate waste fuels. This impacts our carbon footprint by around 16,600 tons of carbon dioxide per annum. And of course, the cost part plays an important role. 192 rupees per ton of clinker from line 3 will be reduced, and the conservation of natural.
Please conclude.
Aspect. Yes, sir. Thank you, sir.
Thank you, Mr. Abhay and Divakar. Now we invite fifth presenter.
Yeah, I'll request the presenter to stick to the time so that we have more time for the question and answer. So next presenter is Mr. Vivek Gupta and Mr. Ashok Agarwal from Shriram Cement Works, Kota. The topic is increasing the consumption of calcium hydroxide sludge as an alternative material for limestone.
Namaskar, brothers and sisters. You may be aware Shriram Cement Works is situated in Rajasthan at Kota. And this plant was installed because we are the only producer of calcium carbide in India. Can somebody help me? Next. You can please go to the next slide. So, when we produce calcium carbide, we have another plant which produces polyvinyl chloride. And there is another plant called as chloralkali. So this is an integrated complex. When we produce calcium carbide and we react calcium carbide with water, we produce calcium hydroxide. And the acetylene gas is taken to the PVC plant where HCl comes from chloralkali. So C2H2 plus HCl makes vinyl chloride. And after polymerization of vinyl chloride, we produce PVC. Now, when we react calcium carbide with water, we get calcium hydroxide sludge. Now, this is an environmental issue. Where to use and throw that calcium hydroxide? We had millions of tons of sludge in the lagoons. So, because of that, this plant came into existence. So, prior to that cement plant commissioning, the disposal of the sludge was a challenge due to management of large size number of lagoons occupying substantial area of the land in addition to the environmental hazards. And sludge is actually rich in lime. It has around 66% of CaO. And this challenge was converted to an opportunity to make a useful product, cement. We had the technology transfer from Lafarge, France. And due to the nature of the raw material, the wet process was chosen, though this process is not energy efficient. Our capacity is very small. We have only 860 tons of clinker a day and correspondingly to around 1,200 tons of the cement. Next, please. So what we actually do is, when we have calcium hydroxide from the calcium carbide plant, we take it to a decanter where the underflow of the sludge is taken and it's taken to another wet ball mill, which is called as raw mill. And there we make a slurry of around 40% moisture. This slurry is stored in 2 slurry mixers, and after a certain process, it is then fed to the kiln. Our kiln is the longest kiln in India. It is 120 meters long kiln. And our thermal energy consumption, as I was talking to you, is 1300 kcal per kg of clinker, which is almost double of what my friends have in their own plants. Now, to limit the slurry moisture to 40%, about 100 metric ton of day water has to be used in the raw mix for the grinding. So there was a challenge that we were not able to use the whole sludge which is getting produced in the calcium carbide plant in our cement plant. Next slide, please. So you can see from the table that the moisture in the sludge from thickener, that is decanter, was 85%. And in order to use the maximize the sludge which we are getting from the calcium carbide plant, we had to have that value of moisture to 72%. So since there is no technology available in the market, an innovative idea with the pilot trials were done by our in-house people. And what we did is, all the time we are talking about the CO2 emission, the carbon, which is the hot topic as of in the world. And what we did is, we reacted CO2 with calcium hydroxide. And we in turn produced calcium carbonate. Now this calcium carbonate, which is heavier than calcium hydroxide, it settles fast. And this resulted in the lower moisture from the thickener. This thickener is called as the decanter. Now, so we did a lot of experiment. On the right side, you find a small photograph. This bubbler type technology reactor was developed in-house to see whether this process is viable for us or not. And this pilot test confirmed that the settling of the sludge improves significantly after its carbonation, and the desired moisture of 68% was achieved from the decanter underflow to increase the sludge consumption in the cement recipe. So my dear friends, this was an internal innovation done by our own people. So this is something which I am trying to tell you. CO2 containing kiln stack gases after the ESP is taken to the gas washer, and the water which we use is again not a fresh water. It is a water because since DCM Shriram has an integrated complex which has 8 different plants. So we bring the water from fertilizer pond, and this whole water is recycled. Zero fresh water is used in the carbonation system. Whatever we are taking intake, it is being sent back to the fertilizer pond. Then through vacuum pumps, these are taken to the carbonation reactors. We have 3 carbonation reactors. Initially there were 2, and then we went for the third one in view of the success of the initial 2. And you find that the carbonated sludge has now gone to 68% of moisture, which was initially more than 80%. So the CO2 present in the kiln flue gases is passed through calcium hydroxide sludge, converts into calcium carbonate. See, this is the picture of the carbonation. Initially we had 2 carbonation reactors, which you are finding, 1 and 2, and then later on we added a bigger one, which was the carbonation reactor number 3. And you will find that why this was done due to 2-3 reasons. First of all, the calcium hydroxide is rich in lime. So we replaced high-grade limestone with calcium hydroxide, which was later on converted into calcium carbonate. So one thing is sure, that we reduce the consumption of high-grade limestone, number 1. We reduce the CO2 emission from the stack and make it environment friendly. And the third thing is the accumulation of this sludge in the lagoons has significantly reduced, and the conservation of limestone. My dear friends, this sludge is now being used for making the bricks also. So you will find that there has been continuous reduction of CO2. In financial year 2022-3, it was 1.03, which is now reduced to 0.90 ton per ton of clinker. So CO2 emission has also been reduced. We can't say it 100% green cement plant, but yes, we are in the direction because there is no technology available as of time. And so calcium hydroxide sludge improved settlement in the thickener, helped in increasing sludge usage in the raw mix as an alternative to high-grade limestone, conserving the natural resources, reducing CO2 generation due to reduced usage of high-grade limestone, and reduced CO2 makes it environment friendly. Thank you so much.
Thank you very much. Now we invite next presenter.
Yeah, next presenter is Mr. KPK Reddy from NCCBM and the Guru Gobind Singh Indraprastha University. The topic is Gasifier design for co-processing RDF in cement industry.
Respected dignitaries on the dais and delegates, we are here for about, the 18th International Seminar on Cement Net Zero Future. In this, we are mostly discussing about how to reduce the carbonate content. Of course, the PAT, which has mostly widely, has reduced around 35% of reductions of CO2 emissions overall of our NDC contributions levels. And as well as, however, if you see about the overall consumption of AFR in India, it is around average is 6%. But however, for some plants, respect to 1 or 2, 3 plants, they are being etching around 35 to 40%, not more than to that. There are some constraints about the moisture in the alternative fuels, and as well as high ash content, and as well as feeding size is also very high, the cost of economics and also availability, right? So my objective is how to reduce your moisture contents effectiveness, and as well as chloride problems are also there. How to reduce those chloride problems, and as well as moisture and ash. How to reduce those things such that my AFR enhancement can be improved to may say around 45% to say 60 to 70% or more. So we have to look into that aspect. This is about, around 77% of waste is disposal in open dumps, and around 18 is composted, and just we are recycling about 5%. In urban, it's generating around 62 million tons of waste annually, and it may reach around 165 million tons in 2030. However, most of the Delhi NCR people may be surrounding the high, stacks of MSW. However, they are being transported to the cement industry, but the consumption level, if you say about, is very less. We have to improve these consumption levels through other methods, because already we are facing many problems in our kilns, especially with high chloride and as well as moisture. Your specific heat consumption is also increasing. Again, and as well as your preheater fan volume, these are all increasing. But we have to look into that aspect, how to increase our TSR, but my specific heat consumption should be lower. But most of the plants are using the moisture of around 35% moisture, means they are having at least for 1% of TSR means they are losing around 0.1 kilocalorie per kg of clinker. So this leads to around, say, for 35% means nearly around 25 to 30 kilocalories they are losing out. So again, specific heat is also increasing. But when you come to up to the CO2 levels, right, it will also increase. But we have to look into that aspect, how to reduce this moisture. Not is about the drying. Drying is another parameter. How my moisture can be enhanced, it can be converted into hydrogen as a fuel in itself. So for that, solutions and all, gasifier is one of the best solutions, such that the moisture which is there in the RDF can be converted into hydrogen and as well as methane, such that this can be used in your kiln systems, the gas composition which is having a methane and as well as hydrogen and CO. This can be used as a combustible material which is having less moisture, and as well as the chlorine percentage can also be reduced furthermore using the RDF. Because generally for RDF generally most of the plants they are getting a chloride around 0.7 or more than 1%. If it is getting more, they are not going to enhance the TSR. So to enhance the TSR, either we have to go for, say, chloride bypass system. Again, that is also heat consumption level point. Moisture is also coming to your picture. So we have to look into the aspects, how to increase your TSR. This is one of the best solutions by going for RDF gasification system. We have done some studies about the RDF gasification to be converted such that enhance the TSR. This is about the integration system for plant, how we can convert the RDF into gasification and then be utilized in your calciner. This is about the gasifiers. You can see there are around 4 types of gasifiers: upward gasifier, fluidizing bed, entrained flow gasifier, and as well as downdraft gasifier. you say about the updraft gasifier, this is well defined in Asian countries like in China and as well as Japan. Mostly they are utilizing this updraft, but however they are facing the problems about the high tar and as well as moisture, conversion of moisture to hydrogen is very less here in the updraft gasifier and as well as in the circulating fluidized bed gasifier where the mixing is very good, but however the controlling is very not proper. So there are other constraints are there designing the downdraft gasifier. Gasifier is one of the solution we have identified where we can control the chloride content as well as ash content and as well as increase your hydrogen conversion ratio while going for downdraft gasifier. This is about, say about a picture of detail about schematic how a downdraft gasifier works where the RDF is being added from the top. Then the drying will take place at around 100 to 150 degrees centigrade, and then pyrolysis takes place. In pyrolysis, around 200 to 70 degrees centigrade, the voltage will be reduced, and then combustion will take place through air, which are being injecting at the point at the throttle, and then the reduction zone. In the reduction zone, mostly your hydrogen, which is moisture, which is there, that will be converted into H2O, H2, and as well as shift reactions also will take place. Producer gas will also form here, and methane will form. And as well as the ash, which is formed, this is nearly, equivalent to your ARA material, which is having a rich in lime and as well as silica material, which can be utilized in your cementitious materials. This is a downdraft gasifier. Generally, most of the gasifiers are designed for biomass. We have studied one of the lab where we have done studies on RDF gasification, especially we have to design with respect to its characteristics. Because RDF size will also impact, moisture will also impact over here for designing a gasifier. Most of the gasifiers, if we use RDF plus biomass in a biomass gasifier, it will be easy. But however, if you want to control over only on RDF gasifier, we have to design it separately with respect to its characteristics. So those things we have done studies and all that we'll be discussing over here. This is about we have done some literature study and as well as done the analysis of various locations of the India across, and as well as we have done some formulation and design and as well as theoretical calculations we have done and some validations in the simulations also we have done. And we will be discussing about the gasifier designs, and this is about the gasifier. While we are designing the gasifier, we have to design about the dryer and as well as the length of the gasifier and as well as the dimensions. Dimensions depends upon your capacity, how much you want the volume of gas, how much you want to have the volume of the gas at the end, and as well as the diameter, height. Height also depends upon each ratio about the moisture and as well as the volatile content in your RDF, how much, and as well as reduction zones. Throttle also depends upon the size of your gasifier. This is about the case study that we have done, having a designing about for a 15 kg per hour capacity and as well as gas seal around 2 nm³ per kg, and having a gasifier capacity of 30 kg of the total volume. And we have, with respect to the calculations, we have achieved about specific gas ratio rate at around 8.42 and having a very less throttle diameter, which having very reducing conditions such that your moisture is converted into hydrogen very much, and as well as the heating value has been increased over here. So this is about the analysis and as well as basic assumptions that we have done about the gasifier design.
Mr. Reddy, please expedite.
This is about the design calculations that we have achieved around, say, height is around 4 meter and as well as 0.153. However, simulation has shown very good results for utilizing this gasifier in the cement kilns. However, the conclusion I would like to say about the syngas produced through gasification has a very good enhancement in the cement kilns, and as well as it will reduce your operation problems like chlorides and as well as ash and consistency problems will be solved while using the RDF gasifier. Thank you. No.
Thank you, Mr. Reddy. So now only 2 presentations are left out, but at the same time there is announcement that dinner is also ready afterwards in hall 1C, that is next to exhibition. So now for remaining two presentations, we invite the presenters, next presenter.
Yeah, the next presenter is Mr. Kiran Mai Sangaravappu. Please excuse me if I have pronounced it wrong. From okay, so Kiran Mai and from Green Innovation, and the topic is overcoming barriers to alternate fuels in the Indian cement industry, technology and solutions for enhanced thermal substitution rate.
Okay, that works. Hi, good evening. I am Miss Kiran Mai, as you can identify. And I'm from FL Schmidt Cement, and I work with green technologies which will help you navigate your net zero journey. And my topic for today is overcoming barriers to alternative fuels in the Indian cement industry. Before I go on to my presentation, I would like to thank my prior presenters who have actually done a great job of introducing what I'm going to speak in my next slides. So, this is how we see your journey of alternative fuels for an average Indian cement plant. It starts from waste sourcing to waste preparation to material handling and storage, dosing, and then putting it into the pyro process systems. We understand that each of these steps might look a little different for each of you in your cement plants. We are not saying that all of this is relevant for all of you, but we are just saying that each of you play a specific role into each of these steps. Of course, we understand based on the kind of alternate fuel you have access to, your plant cycle might look a little differently and your journey might look a little different. Well, I was also hearing all the presenters who were talking about the various substitution rates and the various alternate fuels they have access to. I was wishing I had a solution for all of them. Well, the good news is I do. I have two solutions which I want to talk about today. One is the hot disk reactor, and the other one is the fuel flex pyrolyzer. As we understand the Indian cement industry, we know that the alternate fuels that are available are ranging in size anywhere between 0.001 mm all the way up to 1.2 meters and even higher. So if you are living in a zone or if you have a plant in a zone which has not pre-shredded alternative fuels, not pre-processed alternative fuels, then we would recommend a hot disk reactor, as you can see there. It can handle a range of alternative fuels with various characteristics, with various moisture percentages. And this is something not just what we are saying, this is something that the various installations across the globe of hot disk have seen. Well, but if you are lucky and if you have pre-shredded, structured alternative fuels that you have access to in your plants, then well, of course, I would say go for the fuel flex pyrolyzer, because it can handle relatively coarser materials, but not the high size materials. So let's go through and look at what these two technologies are. Well, hot disk is not new to this industry. Of course, we have celebrated this year 20 years anniversary of the hot disk reactor and its proven performance across the industry, across the various cement plants. We have seen the substitution ranges ranging anywhere between 50% to 80%. There are, of course, outliers where the substitution rate is much, much higher than that. If you ask me, is it something that I should try for my plant? Of course, yes. If you have a plant where we could fit a hot disk, then I would definitely recommend that you upgrade your plant and enhance your total substitution rate at the plant. Well, should I get this if it's a new build? I'm going for a new plant. Should this be part of the business case? Yes, it has to be part of your business cases when you are even thinking of substitution rates to start with in your cement plants. In that case, do you have alternative fuels which tend to release some unburnt material and leave some unburnt residue? Then we would recommend a hot disk with a hot material transport. I think the name is a big giveaway on what that system does. It works on the same functionality as a hard disk, but it comes with added benefits of enabling the hard disk to get rid of the unburned residue and hence helps you in your maintenance as well. But are you those who have separate line calciners in your plant? Then we are actually the only ones in the market who can give you a solution for that. We have a hot disk separate line calciner. In this case, the waste fuel is primarily fired in the calciner, while the hot disk, yes, just completes the combustion of the fuel that goes through it. So these are the 3 variants of hot disk that are available now and not in the far future for you to take care of your substitution rates and actually increase them significantly. So what you have seen are 3 different kind of variations of this proven hot disk, and it will accommodate the various plant layouts without having an impact to performance. In fact, when I mean no impact, I mean it goes higher and better, not lower and worse. So I've also presented you here with 3 proven installations with the 3 variants of hot disk, one in Slovenia, one in China and Korea. I have preferably chosen installations that are from the Asian market so that you could connect better to the kind of alternate fuels that are available and the substitution rates that make sense to this market. As you can see, the substitution rates range from 30% to all the way 85%, and it handles several kinds of alternate fuels with various kinds of moisture. We just heard a presentation by Reddy sir in terms of pyrolysis and gasification. If you missed out some of the details, I would like to also talk about the pyrolysis system. But while I talk about the fuel flex pyrolyzer, I would like to start with congratulating our second installation and a successful launch by Continental Cement Davenport in USA for reaping the benefits of this fuel flex pyrolyzer as we speak. So what exactly is a fuel flex pyrolyzer? It's a compact unit. It enables you to replace the fossil fuels and also control your emissions. So it's a double benefit. It transforms your solid recovered fuel to a very effective fuel stream, and it can be fitted in existing preheater towers. It is working on the basis of pyrolysis, and it has a pulsed fluidized bed that is especially designed and developed to operate with extremely fine cement raw meal, which is also something that we see in these markets. So what do I mean when I say pyrolysis? It's completely different from combustion in the fact that there is no oxygen that is involved in the reactions that are happening in the pyrolysis. By doing that, we have even eliminated the production of NOx and hence effectively reduced the overall NOx in the system. The fuel flex pyrolyzer has 2 U-locks which act as loop seals, or in other words, if you are familiar with piping systems and NRVs, then it is essentially a non-return valve which the fluidized raw meal creates. And through this path, we generate syngas which reacts with the kiln NOx and effectively reduces the NOx. So in conclusion, the fuel flex pyrolyzer helps you in lowering your NOx, reduces your SNCR, and eliminates the usage of ammonia. It lowers the fossil fuel usage. It's a bolt-on installation and requires very less downtime for the tie-in. And based on the business cases that we have worked with some of our customers, we understand that the ROI is anywhere between 1 to 3 years and is of course dependent on local conditions. I just wanted to give you a snapshot of the various alternate fuels we handle through these systems, because that's some of the questions we usually get. Do your systems allow any kind of alternate fuel? Well, it allows all of them that you see over here. It's corn, it's beans, it's tire fluff, it's reject dog food, it's SRF, and so on and so forth. With that,
now I request to
yes,
expedite.
Just give me a few seconds and I'm done. So I just wanted to also present you the results we have obtained at one of our installations. As you can see in the far right, we have reduced the stack NOx by about 20-25% and effectively eliminated the usage of ammonia water. With that, I conclude and invite you to watch us out at the various presentations and of course meet us at the booth. If you have any questions, we are happy to take them afterwards. Thank you.
Thank you. So now we invite to last presenter.
Yeah, last presenter is Mr. Indrendra Singh from ATS Conveyors India Private Limited. The topic is Advanced Materials Handling Solutions for Co-Processing of Alternate Solid Fuels in Cement Plants.
Good evening to Chairman sir and Co-Chairman sir, as well as to all the delegates. So today I am here to give a brief about some of our products as well as a few case studies which we have done with some of our clients. As already lot of detailing about the chemical dynamics as well as other AFR related issues has been already discussed, so I will more be specific into the practical solutions and the products, equipments available with ATS to provide solutions for AFR handling and feeding. This is a basic about the ATS group overview. It is a French company with its installations as well as presence in multiple countries throughout the globe. In India, we have our presence with all the major cement players within the industry. These are some of the key features with ATS dosing systems. So all our systems can easily handle all kinds of ASF, that includes RDF, plastics, municipal waste, biomass, agricultural waste, rice husk, or sawdust, wood chips, etc. As well as we can handle a wide range of density ranging from 0.1 to 1.2 tons per meter cube, along with a maximum grain size to handled within 500 mm with a dosing accuracy of plus minus 0.1%. These are the multiple type of key equipments which are available within our product portfolio for different applications. A bit of details we will be going through in the coming slides. These are the different solutions which we have for AFR handling. It can either be a fully automated storage system along with a grab crane, or it can be a dosing extractor which can be fed either through payloader or through a grab crane. Also we have a side walls belt conveyor for vertical lifting of the material. Also we have a twin doziers for feeding into two different feed points. As well as we have a air floating belt conveyor which is used to convey into some congested environment where there is a plant dynamics is very congested. We can utilize this system in place of conventional belt conveyors. Basically, the loading of material can be done in two ways. Either it can be manual loading or it can be automated loading. Further, we will just go through two case studies which we have done with our one of our commissioned project, and another project is under commissioning. So we'll just like to play the video. So this is a project which is ongoing in Thailand. So presently we have just prepared a simulation video of the same. This project has a fully automated grab crane arrangement for feeding into the extractor along with a dozy floor, which in common language we call it as a moving floor. So there will be these two kinds of extracting system which are feeding into a common line. So depending upon the requirement, the grab crane is selecting the location from where the material is to be picked up, as well as the grab crane itself is deciding the material loading point. Either the material is to be loaded in the storage yard, or it is to be loaded in the extractor or in the dozy floor. So, and this whole system is completely operating based upon a pre-programmed configuration without any manual intervention. Then this material is fed into a common belt conveyor, which takes it further to a air floating belt conveyor, which has been selected considering the plant dynamics, where the requirement was to convey the material in a more safer manner and with a higher inclination, with minimum investment of the steel structures. So this is a air floating belt conveyor, which we call as vault air. And with this system, we are able to achieve a maximum inclination of 20 degrees and a maximum belt speed of 2.5 meters per second, which is far more higher than the conventional belt conveyors. In this, the belt is moving within the metallic pipe, as you can see, and the belt is being supported by airflow instead of carrying idlers, as in the conventional belt conveyors. After this air floating belt conveyor, the material is entering into the preheater building through a belt conveyor and then finally loading into a twin dosiors. This twin dosiors is again a special equipment designed for feeding into two different feeding points with a common hopper for extraction, as well as it has two separate dosing systems. So both these feeding points can be fed with controlled, regulated AFR material. Then we have another case study, which is recently commissioned project. High capacity crane with 10 meter cube grab and overall 16 ton capacity. So with this crane, we have some additional features like anti-sway arrangement is there. So it reduces the cycle time as well as it improves the positioning and risk of damages. Another equipment which we have already seen in the video is dozy floor, known as moving floor in common language. This is another system which can be utilized when you have to store a higher quantity of material and you do not need to have a automated bridge crane. You can just manage the storage using a payloader itself, because this equipment has a higher storage capacity. Then this is extractor, our classical equipment, which is a patented product and sold most of the customers worldwide. It is having an auto calibrator arrangement for the control of extraction. Then this is a twin dosiors arrangement, which as already told, it can be utilized for twin feeding with controlled dosing.
This is an air floating belt conveyor which can be used for different congested environment in the plant dynamics with maximum distance within the support points as well as maximum inclination.
Mr. Singh, please expedite.
Yes, this is the last equipment of the circuit, double flap valve, which is used for maintaining a minimum cycle time for feeding into the feeding points, and all kinds of RDF can be fed through it. It is not restricted for feeding the fine material. That's it. Thank you. For any further questions, you may please visit our stall number 14. Thank you. Thank you.
Thank you, Mr. Singh. So now, forum is open for question and answers. One question from there. Do invite all the presenters to come on stage to reply the questions.
Yeah, good evening. My question to Fornnax.
Yeah, please come on the stage. Yeah.
Yeah, my question is, you are saying about this shredded material. Okay, nowadays what the cement industries are facing the material quality issue, and you are suggesting the primary shredder and secondary shredder. Is there any other pre-processing or pre-treatment are you suggesting before putting into the primary shredder material? Because nowadays cement industries are installing trommel and ballistic separator to remove the stone and innards. So do you suggest anything before that?
Sir, as you have said, it is correct that the waste that we are dealing with is a legacy waste basically. So we have inert is a main key pain area that we are facing right now. So to address it, I will suggest as a OEM that it is better to do the segregation before the primary shredder as well through trommel or the ballistic separators, or so that the machine which we are going to use it is generally for the AFR or the RDF. It is not to shred the stone or the other inert material. So it is better if we can pre-process it before feeding into the primary shredder. Although I will add it on that the machine that we have built as a primary shredder, can handle all kind of waste considering the CND as well. So it is not the limitation of the machine, it is for the better usage of the machine as it is a capex.
Okay, but if we are using the trommel or ballistic, then I think then we can omit the primary shredder.
The primary shredder has as I told you in the layout, which is an ideal pre-processing layout, the primary shredder are generally being utilized to do the only the initial size reduction. But if you will be finding that, as we have seen the presentations of other dignitaries as well, it is been find out that as the size of the material gets reduced, the moisture content and all other things will also get downsized. So that's why the secondary shredder comes into the picture. So to get exact sizing as per to feed into the calciner, secondary shredders are preferable, or else you can also go up with only the primary shredding as an initial phase 1.
But then the size will be the issue. If I remove the secondary shredder, because I required size less than 80 mm, which is given by secondary shredder. Your primary shredder is giving 150 mm size, if I am not wrong.
Yes, so to take care of it, the disc screen is being placed after the output of the primary shredder. So the disc screen can be customized based upon your requirement. So if let's say you need the size of 60 mm for feeding into the system, the disc screen can be customized based on that, so that only the 60 mm will get screened, rest of the material will get refeeded into the system.
Then output will not be reduced. If I am putting the disc screen, primary shredder is only giving the a size of 150 mm. Then total output or maybe the recirculation
so this
will
is
increase.
how, that's why I told in my presentation that this is what is being, we have seen in the existing setup of the cement industries. So this is not the right solution. This is, as I also conveyed. But just as we are entering into this industry and we are now going with the trading process as an AFR, as a complete setup, although not today, maybe in the near future, you have to go with the complete setup of primary and the secondary shader to complete your requirement.
Yeah, thank you. My second question to Marwar Mundra plant presentation. Sir, just to know, what is the chloride range you are finding when you are using MSW? Because we are presently using MSW, and you discuss about the chloride for this Marwar plant. For MSW, what is the range you are analyzing or getting from the MSW?
MSW, it is 0.8 right now.
0.8?
0.8.
Okay. Thank you, sir.
Any more question, please?
Morning to up to evening, everybody discussing about elimination of the ammonia, chloride, like that. If raw material having more fluoride, more mercury, like in Delhi NCR, we done all the feasibility report, including each and everything. What is solution, madam? If raw material having fluoride content and high mercury, fluoride content means what is happen? Our teeth will go out. Our bone will go out. If mercury content means what is happen? Our mind will go out. So if both the things are going, what is solution for alternative fuel? Just only 2 words, madam. Your presentation is excellent. So you are speaking for American and British English also excellent. But we need what is reality of life.
I've never got an appreciation for my English, so thank you for that, because that's not what I was trying to present. But nevertheless, thank you. Coming to your question, well, I interned with a plant where there was a fluorine issue, but it's out of the topic of the presentation today. Would you mind having a discussion later on so that we can talk about it a little more? Thank you.
Thank you.
Okay, one more question, please. No. From there.
My question is for Sharma Cement Works with the carbonation of the sludge. Can you clarify a little bit further, why do you want to pre-wash the gas prior to the reactor?
Which one?
Why do you wash the gas before you get it into your reactor? You have a step before the reactor step where you are washing it with the...
Yes. So in order to take down the dust, which is actually the emissions have got the dust particles also, to settle it down and the gas going to the reactors. That's why the washing is done.
So is it correct that you treat the water afterwards to take out the dust and recirculate it into
Yes,
the
yes. After the washer, then it is taken to the carbonation system, the carbonation bubble reactors.
Okay, thank you.
Thank you.
Okay, so last question, please. From there.
Hello. I have a question for Mr. Ramesh. It is about the alternate fuel. What is the particle size that you are using for your alternate fuel?
It was less than 90 mm, more
Less
than 85%.
Okay. And is there any, it's question maybe for Mr. Keshav. So is there any chlorine limit for the alternate fuel, for any alternate fuel? The limit of the chlorine. Mr. Keshav. Yeah. Actually, I'm asking what is the chlorine limit in the hot limit? How much chlorine should be in the alternate fuel?
Sir, there is no limit in what cement plant is will mange more.
Okay, so
No
there is.
limit is there. You have to be managed. You have to be live with the chlorine, because generally, if we get the standard, then it is earlier it was less than 500 gram per ton of clinker. That is the input control.
Okay.
And in term of this hot mill chlorine, which is more dangerous because it creates the jamming inside the systems.
Okay.
So it creates the jamming. I show you in the slide that we put n number of the air blaster. There is a self-cleaning device. After that also jamming is there. So their manual intervention is there to clean that one. That is the most hazardous job and most safety-oriented job that we have to be take care. So there is no limit. In my slide, there was the one point, we have to find the innovative solution for the co-processing. Why I am saying that 0.3 chlorine, it may be limit for me, but one of my plant, which is nearby the sea, Mr. Just asked me that what is the chlorine limit in the MSW, municipality waste. I told him 0.8.
Okay.
But one of our plant is having 0.1% chlorine in the raw material only. What you will do? Nothing. So best is the 500, but when you use the MSW, any other material, chlorine enriched there. So you have to live with the chlorine, because nobody is stopping us on this 5% TSR, 35% TSR. If we are in the industry, if we are the 35% TSR, my boss next day asked me, why not 50? What you are doing here? So no limit is there, sir. You have to find the own solution.
So, in addition to this, I agree with him. Normally, when the sulfur is not much more, it means reach around 2.5. So if chlorine is up to 1.2, so it is not having the problem. Actually, this is based on the input material also. So particular for, if talking about the Aditya, we are, with the 35%, we are reaching up to 1.2% in hot mill. But at the time, sulfur is always below 2%, 2.1. So in that cases, we never face such kind of any jobbing. So definitely, with respect to natural, with respect to plant, and design also helping to improve the probability and the process optimization. Thank you.
Okay, thank you very much.
Yes. My name is J.S. Kalra from Bureau of Energy Efficiency. My question is to Dr. K.P. Reddy, that whether this syngas which will be produced will be economical for the Indian cement industry or only for white cement. And next may be how to utilize the ash if you are generating the syngas.
Sir, it is not only for white cement, but it can also be used for dry cement, gray cement plants also. You can enhance your TSR because of a lot of constraints, most about the moisture content, they can't dry, right? Here, my moisture is converted into hydrogen. So this will act as a fuel to me. And next is ash. Ash which is generated that can be utilized as an cementitious material. Further testing has to be done on this point. Yes, sir. That is why generally at present we can't segregate our RDF, which is having a 35% moisture, and this 35% moisture and as well as around 20 to 25% ash is there. These things will be, and as well as chloride. These three combined, you can't increase your TSR to maybe say 30-35%, not more than to that. So to look in these three components, if we going for a gasifier where you can clean, say you are getting a clean combustible gas, is having a CV of around 2000 to 3000 kilocalories per meter cube. It can be used. So it will be beneficial, and as well as operation problems can be reduced. Of course, you can increase your TSR on this point.
Adding on to what Reddy Sahab has just said, it works on the same principle, the fuel flex pyrolyzer, producing that syngas and char and water vapor. So along the similar lines of what Reddy Sahab has said, and I can confirm it works in grey cement because we have 2 installations which are grey cement. So we'll come to your start tomorrow. Definitely, please do.
There are any more questions? Presenters can be contacted directly for face-to-face discussion or any additional questions. Now I request co-chairman to summarize.
Be standing between all of us and the dinner, so I'll just have a couple of points to make. So as you know, the alternative fuel is very close to the heart of Indian cement industry. We saw there's a huge potential, but currently the levels are very low. Out of 8, if you see the 4 presentations were for them from the cement plants. So those who are really putting a serious efforts in increasing the alternative fuel with some unique features. And there was a couple of 3 presentations, in fact, from the technology providers. So there is a cement industry, the plants interested to increase the AFR. At the other side, there are technologies which are available and also supported by one paper from the institute, a research institute, which talked about the top-down gasifier. So it was a quite interesting and very well researched thought papers presented by all the speakers. I compliment them, and I really look forward to having more interactions during the next 2 days on this AFR. Compliments to all of you.
So first of all, I thanks to all the presenters for their good presentations. Only just few points from my side. So now alternative fuel and alternative materials are the pathway to reduce the carbon footprint in cement manufacturing. However, it is noted that in last 1 decade, everyone is putting their efforts to find the new alternative fuel or alternative materials. But still there is need to find some more. It is not only environmental beneficially, but having economic or financial advantage also. But at the same time, there is further requirement of technical innovations. So some plants are putting really their serious effort to enhance the TSR and finding the solution at their end. But at the same time, it will be advisable if there is some sort of forum where each and everyone can put their best practices, so which can be used by everyone. Surely, there will be, to enhancing further alternative fuels and further alternative raw materials, there will be need of some considerations and regulations, and some policy support will be required. For example, if there is possibility to enhance the fly ash to 40%, why not? If we are maintaining the quality and we are maintaining the strength and other aspects. So, I will not take much time now. Dinner is ready. So, once again, thanks all for their good presentations.
I request our chairman and co-chairman to felicitate our presenters with certificate of participation. The presenters are Shri Keshav Katare, Shri Ramesh Kunuku, Shri Abhay and Divakar, Shri Vivek Gupta and Ashok Agrawal, Shri KPK Reddy, Ms. Kiranmay, Mr. Indendra Singh. I request Dr. Pinky Pandey to honor our chairman and co-chairman with a memento.
Hello. Your attention, please, ladies and gentlemen. The signage of the 18th NCB International Conference is now being displayed prominently on the front facade of the main building of Yashobhumi on its digital display at the top. It makes for a very pretty sight. If you want to click any pictures there, you're more than welcome to do so. Thank you.
With this, we come to the end of our today's technical session. Thank you for your presence, participation, and patience. I request everybody to join us for the dinner, which is hosted by UltraTech Cement Limited, which is in Exhibition Hall 1C.